Hi, if you would like to analyze your data and you choose few of your variables and would like to decide if they related to each other, maybe you wanted to also decide if they are quite random or prove they are not connected to each other. You have the choice of correlation coefficient. Correlation is a statistical technique describes the strength of between two variables. Correlation not just only help you to show the relation between your variable and your data, but also by how much x and y they vary together. We can use, of course, any data analysis tool, including Excel or R, to calculate the correlation coefficient. But you expect to know how the correlation coefficient being calculated. In this tutorial, I will explain all the steps involved to calculate the correlation coefficient, taking into account all the learners from all levels. Most tutorials, they did cover the correlation coefficient calculation in a quite fast way, even manually calculated. I'm going to include these values on this tutorial below in the description. Feel free to download it, use it, and also I encourage you to change these variables. Hope you will enjoy it. It is very simple, and I assure you that if you watch at the end, anyone can easily calculate the correlation coefficient. First, we need to learn simple things and calculate the following. We need to find out the mean of x and y, and also we need to find out the variance of x and variance of y. Finally, we need to calculate the covariance of x and y. The mean is to add up all the x value, count how many they are, divided by 9. After we find out the mean of x and the mean of y, we can then go ahead and calculate the variance of x and variance of y. To calculate the variance of x is to calculate sigma x squared over n minus the mean square. The mean square we just worked out was 5. To calculate sigma x squared mean that I'm going to add up or square all the x value and then add them up, divided by n. I can easily find the covariance of x or y by add these figures together. Now, after we find out the mean of x and mean of y, the variance of x and variance of y, we can calculate the covariance of x and y. And to work out this, we need to multiply x value by the y value and then sum them up. And that means we need to add another row to this table called xy. And to work out this, we need to multiply the x value by the y value, then sum them up. 1 multiply 5 by 5, and sum up the total of the sigma squared xy. Now we have done that. Easily we can quite work out the covariance of x and y. So to calculate the covariance of x and y, you might guess it by now, it's already done similarly on the variance of x and the variance of y. The difference here, that the variance of x was the mean of x squared itself. On this time, we are using both of them, x and y, and we are using the mean of x squared not by itself, but by the y. Sigma xy was by adding all these together. Our n, same still n. Our mean of x we worked out before was 5. Sticking all these figures into your calculator, it will give you this answer. So by now, we learn how to work out the following: the mean of x and y, the variance of x and y and the covariance of x and y. Now we have done that, we can go a step further, which is going to lead us to calculate the correlation coefficient R. We learned that covariance and variance will tell us if these variables are varied together, but calculating the correlation coefficient gives us more precise measurement, which is giving us the measurement of the correlation between x and y. Now, because we calculated the covariance of x and y, and because we calculate the variance of x and y and the mean of x and y, we can easily calculate R. So our R is the covariance of x and y divided by the square root of variance of x multiplied by the square root of variance of y. So we know our variance before. Stick all these figures into calculator. We can find the answer of our correlation coefficient equal 0.95. That's great. What does mean this answer really? So the measurement of the correlation coefficient and the result measured on a scale varies from 0, -1 and 1. If the result of our correlation coefficient have negative value, then that means they got relation, but they have negative linear correlation between them. However, if they have positive linear correlation, anything more than 0.50, then they have positive linear correlation. If they have no correlation or no relation between them, they quite often lie around the 0. Now, you might guess it. If we plot our data, we can see we have positive linear correlation because our value is lie on the measurement of very strong correlation between 0.8 and 1. As I mentioned, we can quite easily calculate the correlation coefficient using R. I have already imported the dataset on R language, 9 variables. I will easily calculate it using the correlation coefficient by just adding COR before X and Y. And as you can see, we have the same value, which is quite easily can be calculated on any data analysis tool. However, if I will also plot this observation, we can see there is graphically very obvious positive linear relationship between these variables. Thank you for listening. I hope that you learned something today on how to calculate the correlation coefficient manually and easily. Please leave a comment below if you have any questions.